Imagine standing in a vast, silent library, the universe itself. Every book is a star, every shelf a galaxy, and the silence is so deep, it almost hums. You're surrounded by endless knowledge, but most of it is locked away, waiting for someone to listen, to discover its secrets. In this cosmic library, the stories are written in light and sound, in signals that travel for years across the darkness. For decades, scientists have listened to this cosmic quiet, hoping for a sign that we're not alone. They point their instruments at the sky, tuning in to the faintest whispers, searching for a message that might change everything we know about our place in the universe. One day, among the static, a strange, clear whisper was heard, a sound that didn't belong. It was as if, for a brief moment, the universe itself leaned in and spoke directly to us, breaking the endless hush with a single, unmistakable note. It was a moment that made everyone stop and wonder. What was that? Was it a mistake, a trick of the equipment, or something truly extraordinary? The room filled with a sense of awe and possibility, as if the boundaries of what we thought we knew had suddenly shifted. For centuries, we've looked up and asked, are we alone? Are there others out there looking back? From ancient storytellers to modern scientists, this question has echoed through time, inspiring dreams, myths, and now, scientific quests that reach across the stars. Finding a mysterious signal is like hearing a faint cough in the next room. You don't know who it is, but you know someone's there. It's a subtle hint, a gentle nudge that makes you lean forward, heart pounding, wondering if you're about to make contact with something, or someone, beyond your wildest imagination. This is the story of one such cosmic cough, a signal from our closest stellar neighbor. Proxima Centauri, a small, faint star just over 4 light-years away, became the focus of global attention when a signal unlike any other was detected coming from its direction. In space, signals are invisible waves, like the ones that bring radio to your car. They travel vast distances, carrying information across the emptiness, sometimes for millions of years, before finally reaching a waiting ear or a sensitive instrument on Earth. Most signals are natural, the rumbles of stars, the pops of galaxies, the background music of the cosmos. These are the sounds of creation itself, the ongoing symphony of the universe unfolding over billions of years. But sometimes, we find a signal that's neat, orderly. Something nature rarely makes. Patterns that repeat, signals that stand out from the chaos, as if someone, somewhere, is trying to get our attention. These are the signals that get scientists excited. They spark debates, late-night meetings, and a flurry of activity as researchers try to rule out every possible explanation, except the most thrilling one. So, let's journey across trillions of kilometers to Proxima Centauri. Imagine traveling beyond our solar system, past the familiar planets and into the vast, uncharted darkness, to a place where a single signal could mean we're not alone. We'll see how scientists use giant metal dishes to listen to the cosmos. These telescopes are our ears on the universe, patiently scanning the sky, collecting whispers from the stars, and turning them into data we can study. And we'll investigate a mysterious whisper from that direction, a signal that made the world hold its breath. News spread quickly, capturing imaginations everywhere, as people wondered if this was the moment we'd finally made contact. This is a detective story, with the universe as our crime scene, and a single, faint beep as our clue. Every piece of evidence matters. Every possibility must be explored, as we try to solve one of the greatest mysteries of all time. The universe is talking, and we're just learning how to listen. Each new discovery brings us closer to understanding our place in the cosmos, and maybe, just maybe, to finding out we're not alone after all. It's an amazing time to be alive. We stand at the edge of discovery, united by curiosity and wonder, ready to hear whatever secrets the stars might share. Are you ready to listen? Let's begin our search for the whispers from the stars. Let's take a journey through our cosmic neighborhood, a vast expanse filled with wonders and mysteries waiting to be explored. When we look up at the night sky, we see countless stars twinkling above us, but only a handful are truly close in astronomical terms. Earth orbits the sun, our life-giving star, but it's important to remember that our sun is just one of hundreds of billions of stars scattered throughout the Milky Way galaxy. Each of these stars could have its own planets, its own stories. The closest star system to us is Alpha Centauri, a fascinating trio of stars bound together by gravity. This system is just over 4 light-years away, making it our nearest interstellar neighbor. Of the three, the smallest and faintest is Proxima Centauri. Despite its dimness, it holds the title of being the closest star to our solar system, making it our nearest stellar neighbor in the vastness of space. Proxima is a red dwarf, small, cool and glowing, with a subtle reddish light. Red dwarfs like Proxima are the most common type of star in our galaxy, but they're so faint that none are visible to the naked eye from Earth. If our sun were replaced by Proxima, Earth would be plunged into a deep freeze, shrouded in darkness. The warmth and light we take for granted would vanish, and our planet would become a frozen, lifeless world. But Proxima Centauri is fascinating for another reason. It has at least one known planet, Proxima b, orbiting around it. This discovery has sparked the imagination of scientists and dreamers alike. Proxima b orbits within what's called the habitable zone, the region around a star where conditions might be just right for liquid water to exist on a planet's surface. This is sometimes called the Goldilocks zone, not too hot and not too cold. Where there's water, there could be life. The possibility of even simple life forms existing on a planet so close to us is both thrilling and humbling. That's why Proxima Centauri has become a top target for astronomers and scientists searching for life beyond Earth. They use powerful telescopes and sensitive instruments to study its light and search for clues. When a strange, unexplained signal was detected coming from the direction of Proxima Centauri, scientists around the world paid close attention, eager to unlock its secrets. The nearest star system is the most logical place to look for a neighbor. If intelligent life exists elsewhere, it might be just next door, in cosmic terms. Could someone, or something, be living next door to us, orbiting a tiny red star just 4 light-years away? That's what makes the story of Proxima Centauri so compelling. A nearby world, a possible home for life, and a mystery that continues to inspire our search for answers in the universe. We call Proxima Centauri close, because in the grand scheme of the universe, it's the nearest star to our sun. But what does close really mean when we're talking about the cosmos? In space, distance is a matter of perspective. Even our closest neighbors are unimaginably far away by human standards. Proxima Centauri is about 4.2 light-years away. That's 40 trillion kilometers, or about 25 trillion miles. It's a number so big, it's almost impossible to picture. If you could somehow drive a car there, never stopping for food, sleep, or fuel, it would take you over 45 million years to reach Proxima Centauri. That's longer than humans have even existed on Earth. Even our fastest spacecraft like Voyager would need tens of thousands of years to make the journey. Space travel as we know it is just not fast enough for these distances. To help imagine it, picture the sun as a grapefruit sitting in London. Proxima Centauri would be another grapefruit all the way in Cairo, with almost nothing in between. Space is mostly empty, a vast ocean of darkness. If we sent a message traveling at the speed of light, it would still take 4.2 years to arrive at Proxima, and another 4.2 years for any reply to come back. Communication across these distances is like sending a letter and waiting nearly a decade for a response. Every time we look at the stars, we're not seeing them as they are now, but as they were years, decades, or even millennia ago. We're peering into the past, catching glimpses of ancient light. The signal we detected from Proxima Centauri left that star over 4 years ago. We're always receiving messages from the past. This time delay is a fundamental part of astronomy. It shapes how we study the universe and understand our place in it. The vast distance makes any signal from Proxima incredibly significant. Each one is a rare and precious clue from a faraway world. We're not just listening across space, we're listening across time, tuning in to echoes from the distant past. That's why every whisper from the cosmos matters. Each signal could change what we know about the universe. The universe's history is written in light, and every beam that reaches us is a message from across both space and time. How do we listen to whispers from trillions of kilometers away, across the vast emptiness of space? We use radio waves, an invisible form of light that travels across the universe, carrying secrets from distant worlds. Radio telescopes, like the Parkes Observatory in Australia, act as giant ears, collecting faint signals from space that our eyes can't see. These enormous dishes gather radio waves and focus them onto sensitive receivers, amplifying even the weakest signals. But space, and Earth, is noisy, full of interference from human technology and natural cosmic sources. Astronomers filter out this noise, searching for signals that appear only when pointed at a specific star or region. If a signal vanishes when the telescope moves away, it gets interesting and might be worth a closer look. It's a cosmic game of hide and seek, played on a scale beyond imagination. The Breakthrough Listen project is humanity's most ambitious search for alien signals. Using the world's largest radio telescopes, they scan millions of stars, including Proxima Centauri. In 2019, the Parkes telescope observed Proxima, collecting mountains of data. Over a year later, intern Shane Smith sifted through this data, searching for artificial signals. He looked for narrow drifting signals, what you'd expect from a planet orbiting a star. Then, something caught his attention. Shane's computer flagged a signal. Unlike the usual cosmic noise, it was narrowband, focused at one frequency, like a clear whistle. Natural sources are broad and messy. This was precise, like technology. The signal drifted in frequency, just as you'd expect from a transmitter on a moving planet. Most intriguingly, it appeared only when the telescope pointed at Proxima Centauri. When the telescope moved away, the signal vanished. This made it unlikely to be random Earth interference. The signal was named Breakthrough Listen Candidate 1, BLC-1. It was the most promising candidate for extraterrestrial intelligence ever found by the project. Scientists checked every possibility: satellites, interference, equipment errors. For a moment it seemed like the whisper from the stars was real. The detective story had its first big clue. The world held its breath. Time for detective work. Good science means ruling out every ordinary explanation first. Could BLC-1 be a human-made signal, a satellite, or a glitch? The team checked satellite records. Nothing matched. No other telescope saw the signal at that time. The most likely culprit: radio frequency interference from Earth. After months of investigation, they found fainter signals with similar patterns, matching human technology. The conclusion: BLC-1 was a rare, but earthly signal that mimicked what an alien message might look like. It was a case of mistaken identity. The whisper was just an echo of ourselves, but the mystery taught us a lot. But what if BLC-1 had been real? A confirmed signal would be the greatest discovery in human history. It would prove we're not alone, that life and intelligence have arisen elsewhere. Even a simple beep would change our place in the universe forever. It would spark new questions, new explorations, and a new sense of connection. The thrill of the unknown keeps us searching. BLC-1 was a false alarm, but it proved our technology works. Each false alarm teaches us to be better, to filter out noise, and to refine our search. The search for extraterrestrial intelligence is a marathon, not a sprint. The universe is vast, hundreds of billions of stars, and even more planets. Listening to one star for a few hours is like dipping a cup in the ocean, hoping for a marked fish. But if we keep listening, our chances grow. We've only just begun. All over the world, telescopes are listening for the next signal. Curiosity drives us forward. Are we alone? It's the biggest question we can ask. The story of BLC-1 isn't failure, it's progress. The universe is full of mysteries, waiting to be solved. We keep listening, keep exploring, and keep hoping. The stars are waiting. For millennia, humans have gazed at the night sky, captivated by its beauty and mystery, wondering about our place in the vast universe. Driven by a relentless urge to explore, we have always sought to understand what lies beyond the familiar. This curiosity led our ancestors to cross oceans and scale mountains, pushing the boundaries of the known world in search of new horizons. Always wondering what lies beyond, they ventured into the unknown, guided by hope and imagination. The moon and planets have inspired myths, guided explorers, and sparked our imagination for generations, shaping our understanding of the cosmos. We are, at our core, explorers, drawn not to escape Earth, but to expand our horizons and seek new possibilities. Our stories, from ancient legends to modern science fiction, reflect this cosmic longing, echoing our desire to reach for the stars. The Earth is our cradle, but we were never meant to stay here forever. Our destiny lies beyond our home planet. The universe calls us to adventure, challenging our intelligence, our courage, and our creativity. The 20th century transformed this dream into reality. We built rockets, sent probes, and reached farther than ever before. We set foot on the moon, leaving our mark on another world for the very first time. That first lunar step was more than a political victory. It was a promise fulfilled for all humanity, a symbol of what we can achieve together. Suddenly the frontier was not a distant land, but the vastness of space itself, waiting to be explored. Today the dream burns brighter than ever, inspiring new generations to look up and wonder. Armed with knowledge and technology, we stand ready for the next leap, preparing for journeys that will take us farther than ever before. The question is no longer if we will leave Earth again, but when and how we will reach new worlds. The universe has laid out an infinite roadmap, and we are just beginning to explore its endless possibilities. The next chapter of our story will be written among the stars, as we continue our timeless journey into the unknown. Our next frontier isn't distant star systems or far-off galaxies shimmering at the edge of our imagination. Instead, it lies within our own cosmic neighborhood, right here, in the space that surrounds our home planet. The moon, just 3 days away by spacecraft, is rich in resources and scientific secrets, a perfect stepping stone for humanity's next giant leap. It's a historical archive, preserving billions of years of solar system history, a potential launch pad for deeper missions, and a unique platform for groundbreaking science. Mars, the mysterious red planet, has long captured our imagination and inspired generations of explorers and dreamers. With its thin atmosphere and frozen water locked beneath the surface, Mars could one day host a self-sustaining human presence, opening new chapters in our story. Reaching Mars would make us a truly multiplanetary species, a profound leap for humanity, and a testament to our curiosity and resilience. Orbital habitats like the International Space Station are our first homes in space, where we learn to live, work, and thrive beyond Earth's atmosphere. Future stations could become bustling orbital cities, advanced manufacturing hubs, and vital gateways to deeper space exploration. These destinations, the Moon, Mars, and orbital stations, are vital, each teaching us how to adapt, innovate, and survive beyond Earth. The Moon is our workshop, Mars our second home, and orbital stations our training grounds for the challenges ahead. Together they form a logical, interconnected path outward, a roadmap for humanity's expansion into the cosmos. This is how we begin our journey into the unknown, forging a future among the stars, step by step. Leaving Earth is the most complex challenge we've ever faced. Astronauts train for years, mastering science, engineering, and survival. They endure simulations of launch, weightlessness, and isolation until every emergency response is instinctive. Mission planning is a dance of physics and logistics. Timing, trajectory, and resources must align perfectly. For Mars, launch windows open only every 26 months, making timing critical. Building the hardware is a feat of engineering. Rockets must be powerful, yet light. Spacecraft must be self-sustaining worlds. Every system is designed for survival: air, water, food, and safety. The mission plan details every moment, with contingencies for hundreds of possible failures. In space, there's no room for error. Behind every mission are thousands of hours of preparation and teamwork. This is the invisible scaffolding that makes exploration possible. In space, survival depends on mastering the basics: air, water, food, and safety. Every aspect of daily life must be carefully managed, as the smallest mistake can have serious consequences. Astronauts must be vigilant, resourceful, and adaptable at all times. Spacecraft and suits must provide a breathable atmosphere, recycling every molecule of air. Oxygen is precious, and carbon dioxide must be removed efficiently to keep the crew healthy. Advanced filtration and monitoring systems are always at work. Water is precious. Every drop is reclaimed and purified, even from sweat and breath. In microgravity, water behaves differently, so special systems capture and process it for reuse, ensuring nothing is wasted. Advanced recycling systems, pioneered on the ISS, are essential for long missions and could help solve water shortages on Earth. These closed-loop technologies are a testament to human ingenuity and may one day benefit communities worldwide. Food has evolved from bland paste to a variety of meals, but future missions will rely on growing crops in space. Nutrition and morale are closely linked, so providing tasty, healthy food is a top priority for mission planners. Experiments have already shown we can grow lettuce and radishes using hydroponics and LED lights. These successes pave the way for more complex crops, bringing us closer to sustainable off-world living. Space is dangerous. Micrometeoroids, radiation, and vacuum require robust shielding and redundant systems. Even a tiny puncture or a burst of solar radiation can threaten the entire mission. Spacesuits are personal spacecraft, protecting against extreme temperatures and hazards. Each suit is a marvel of engineering, designed to keep astronauts alive in the harshest conditions imaginable. Every system has backups, and every backup has another backup. This layered approach ensures that even if something fails, there's always a way to stay safe. Redundancy is the key to survival in the void. Astronauts train for every possible emergency, preparing to respond quickly and effectively. Off-world life is a constant battle against an unforgiving environment. Yet, with determination, teamwork, and technology, humanity continues to push the boundaries of what's possible beyond our home planet. Space travel pushes our technology and biology to the limit. The moon is 3 days away, but Mars is over 33 million miles, a 6 to 9 month journey. Communication delays, up to 22 minutes each way, make real-time contact impossible. The vacuum of space is relentless. Any breach is catastrophic. Spacecraft must be engineered to perfection, shielding against radiation and wild temperature swings. Microgravity weakens bones and muscles, so astronauts exercise 2 hours daily to stay healthy. Fluids shift in the body, affecting vision and brain pressure. The psychological toll is immense. Months in a confined space, isolated from Earth, test mental resilience. Crew selection and support are as vital as engineering. Every challenge, from distance to isolation, demands innovation. The journey is perilous, but each obstacle brings us closer to the stars. This is the price of exploration. For every challenge, we invent new solutions. To cross vast distances, we're developing advanced propulsion like solar electric propulsion, gentle but relentless, pushing spacecraft farther than ever. Closed-loop life support systems recycle air and water, aiming for near self-sufficiency. The ISS's environmental control and life support system is a marvel, turning waste into resources. To fight microgravity's effects, astronauts use custom exercise equipment, and scientists explore artificial gravity through rotating habitats. Psychological health is protected by careful crew selection, structured routines, and even virtual reality escapes. Future spacecraft will use design, lighting, color, layout to boost well-being. Every innovation, from propulsion to psychology, brings us closer to thriving in space. Ingenuity is our greatest tool. We adapt, we overcome, and we keep moving forward. The hostile void becomes a new home through human creativity. The journey to the frontier is happening now, led by real missions and bold organizations. NASA's Artemis program aims to return humans to the moon, this time to stay, with the Gateway outpost as a launch pad for Mars. Private companies like SpaceX are revolutionizing access to space with reusable rockets and the ambitious Starship, designed for interplanetary travel. Space exploration is now a global effort. ESA, China, India, Japan, and others are all reaching for the stars. Robotic missions like Perseverance and Curiosity scout Mars, searching for life and preparing for human arrival. Every mission, every launch adds to our knowledge and reduces risk. The ISS is a testbed for living and working in space. These efforts are the modern voyages of discovery, pushing boundaries step by step. The dream is becoming reality, one mission at a time. The path to the stars is being paved today. Imagine waking to a Martian sunrise, your day shaped by survival and discovery. Life on the moon or Mars means living in compact habitats, shielded from radiation, where every system is vital. Days are filled with science, maintenance, and exploration, venturing outside in a spacesuit, searching for water, or tending crops in a greenhouse. Every action is deliberate, every discovery could change our understanding of the universe. Inside, you maintain the ecosystem, grow food, and conduct experiments. Exercise is essential to fight the effects of low gravity. Communication with Earth is slow, but sharing your experiences connects you to home. Companions become family and support system. Life is a balance of awe and relentless work, a testament to human resilience. On the frontier, survival and wonder go hand in hand. Exploring space is more than science, It's an investment in humanity's future. Technologies born from space travel improve life on Earth, from GPS to water purification. Becoming multiplanetary is the ultimate insurance for our species, ensuring our story continues no matter what happens on Earth. Space exploration gives us perspective. Seeing Earth as a fragile blue marble unites us. Projects like the ISS show what we can achieve together, beyond borders and conflicts. The future of space is a future of hope and ambition. It's a promise to keep dreaming, innovating and reaching higher. The stars are not just distant lights, they are our destiny. The journey will be long and hard, but it's one we must take. In reaching for the heavens, we discover the best of ourselves. The next frontier awaits. The universe is vast, filled with worlds beyond imagination. For centuries, we've gazed at the stars, wondering if we're alone. Now, our ship, the Odyssey, approaches a new world, Ethel. On the main screen, Ethel grows, a marble of swirling blues, greens, and rusty orange. My heart races. We're about to become part of this world story. Every calculation must be perfect. There's no room for error. My crewmates and I exchange looks of nervous excitement. We're explorers on the edge of the known, stepping into a new chapter of human history. Silence fills the cockpit. The final countdown begins. The adventure is about to start. The ship shudders. The descent has begun. We enter Ethel's upper atmosphere, a soft orange glow outside the windows. Friction turns the ship into a fiery arrow streaking through an alien sky. The forces press us into our seats, but the emotional intensity is greater. We're falling through the sky of another world. The colors outside shift from orange to fiery red, then to soft pink as we slow. The worst of entry is over. Parachutes deploy. Our descent slows. Now, we drift through lavender clouds, parting like a curtain. Below, Ethel's surface appears, a patchwork of purple plains and glowing forests. The ground gets closer. The landing site is a wide, flat plain. The ship's legs extend. Engines fire in short bursts, guiding us down. My hand rests on the controls. We're just meters away. Purple dust stirs around us. We're here. The final seconds stretch out. The world outside is alien, but it's not hostile. The ship settles. Silence. We made it. We're on the surface of another planet. The adventure is real. The next step awaits. A soft bump, a gentle settling, then silence. The engines cut out. The only sound is the hum of life support. The ship's computer. Touchdown confirmed. Welcome to Ethel. Relief and awe wash over us. We look out at a vast plain of purple sand, jagged black mountains in the distance. The sunlight is golden, casting long, strange shadows. This world feels ancient, silent, and beautiful. The mission commander's voice. Begin post-landing checks. Prepare for surface excursion. We check every system, analyze the atmosphere. The air is thin, cold, but free of toxins. The world is alien, but not hostile. Checks complete. We're cleared for the first step. Dr. Eris Thorne and I are chosen to go first. We move to the airlock. Suits sealed. The inner door closes. Air is pumped out, replaced by our tanks. The outer door opens. A ramp extends to the purple ground. This is it, the moment of truth. The culmination of a journey that began with a simple question. What else is out there? We're ready. The ramp touches down. Golden light floods the airlock. My heart pounds. The first step is moments away. The universe is about to answer. We step forward. The ramp touches the purple dust of Ethel. I stand at the top, heart pounding, breath loud in my helmet. I think of Neil Armstrong, one small step, a giant leap. I walk down slowly, each step deliberate in the lighter gravity. My boots crunch softly, purple dust swirls. At the bottom I take the final step. I'm the first human on a planet outside our solar system. Awe, humility, and joy flood me. I look back at the Odyssey, our lifeline, now a visitor in this silent landscape. I turn to the vast plain. The silence is absolute. No wind, no sound, just a world waiting for visitors. My voice shakes as I speak. I'm on the surface. Eris follows, standing beside me. We look out together, two small figures in a vast wilderness. For a moment we're just people, staring in wonder at the universe. We've reached a new world. The adventure has truly begun. The silence is profound. The universe feels closer than ever. We take it all in. I look up at Ethel's sky, a soft, pale turquoise stretching endlessly. Two suns hang above, one golden, one silvery white. Their combined light bathes the land in an ethereal glow. Each object casts two shadows, overlapping and strange. Wispy lavender clouds drift slowly, catching the twin suns' light. The stars are unfamiliar. Earth is just a distant pale dot. Suddenly, a shimmering curtain of light appears, an aurora that dances across the entire sky. Ribbons of green, pink, and violet pulse in a celestial ballet. The planet's magnetic field and stellar winds create a light show on a planetary scale. Seeing it with my own eyes fills me with wonder. The universe's creativity is boundless. Every new world teaches us more. This sky, with its two suns and dancing lights, is a reminder of how much there is to discover. We are explorers on the shore of a vast cosmic ocean. The journey is just beginning. We move away from the lander, drawn to a strange formation, a garden of alien plants. Tall, glossy black stalks spiral upward, crowned with crystalline structures. The crystals glow softly, blue, green, amber, pulsing like slow-beating hearts. The garden is alive with rhythmic light, mingling with the golden suns. I touch a stalk, smooth, cool, like polished stone. These are not plants as we know them. Eris scans one silicon-based life, absorbing light through their crystals. They're living solar panels, a form of life we'd only theorized. The reality is more beautiful than any theory. We walk deeper, surrounded by glowing structures. The air is still, the only sound our boots on purple dust. It feels like a sacred place, a cathedral built by nature. We take samples, document every detail. Every discovery adds to our understanding of life. We came seeking knowledge and found wonder. This garden is a testament to the diversity of life in the cosmos. Life takes forms we never expected. The universe is more creative than we imagined. We are humbled by what we find. The adventure deepens. In the crystal garden, I spot movement, small, iridescent creatures with 6 delicate legs. They shimmer like insects made of metal and pearl, darting among the stalks. They climb and drink light from the glowing crystals. I crouch to observe one. It pauses, watching me with obsidian eyes. There's intelligence and curiosity in its gaze. I stay still, not wanting to frighten it. This is our first encounter with mobile alien life. Eris joins me. More creatures appear, moving in a swarm. They communicate with clicks and whistles, picked up by our suit sensors. They're discussing us, the new arrivals. We must look like giants, strange ghosts in their garden. One approaches my glove, peering up at my helmet. In this moment I feel a connection, separated by evolution, but united by curiosity. We share the desire to understand our world. On this distant planet, we are not so different. The encounter is delicate, profound. We are guests in their world. The universe is alive with possibility. We move carefully, respecting their space. The first contact is peaceful. We explore the purple plain, discovering it's far from empty. Patterns in the dust, tracks of small and large creatures, hint at a complex ecosystem. We follow large tracks toward the Black Mountains. They're old, dust-settled, but clear. There's more life here than we imagined. The world has predators, prey, and a history written in the dust. We find strange geological formations, shaped by ancient wind and rain. The climate has changed. Ethel was once different. Studying its past helps us understand planetary life cycles, even Earth's future. As the twin suns set, the landscape glows red, shadows lengthen. The crystal garden brightens in the fading light. New sounds reach our sensors, calls and whispers from the darkness. Night awakens the world. It's time to return to the lander. We've only scratched the surface. Every discovery brings new questions. This world has secrets. We're just beginning to listen. The adventure continues tomorrow. The unknown calls us back. We are eager to return. Back inside the Odyssey, we remove our suits, tired, exhilarated. We examine our treasures, glowing crystals, purple dust, streams of data. Each tells a piece of Ethel's story. We've taken humanity's first steps on a new world. We've met life that grew from a different seed. The universe is full of surprises. This is just the beginning. Ethel is one world among billions. Some are barren, some raging giants, but some cradle life and wonder. We have a duty to explore, not just for science, but for the human spirit. Curiosity drove our ancestors across continents. Now it leads us to the stars. Exploration is hard, dangerous, but essential. It expands our perspective, reminds us we're part of something bigger. Each new world teaches us about our own. Earth becomes more precious, more fragile. Exploring the cosmos is also exploring ourselves. Tonight, as the two suns set over Ethel, I am filled with hope. Hope for a future where we reach for the stars together. We are a young species, just beginning our journey. The universe is waiting. More shores, more skies, more wonders await. Our greatest voyage has just begun. Look up. Let your eyes adjust to the darkness, and let your mind wander beyond the familiar. On a clear night, far from city lights, the sky reveals its true self, a vast, dark canvas sprinkled with countless points of light. Each one is a silent beacon, a reminder of how immense the universe truly is. Each of those lights is a sun, a star, perhaps with its own family of planets. Some may even have worlds not so different from our own, orbiting in the quiet dark. For as long as we've been human, we've stared into that darkness and wondered. The night sky has always been a source of questions, hope, and inspiration. We told stories about the constellations, imagined gods and heroes among the stars. Our ancestors drew maps in the sky, connecting the dots with tales of adventure and mystery. This deep curiosity is part of what makes us who we are. It's a spark that has fueled our creativity and our desire to understand the unknown. It's the engine of discovery, the whisper that asks, "What's out there?" That question has echoed through generations, shaping our dreams and ambitions. It drove our ancestors to cross oceans, climb mountains, and map our world. The urge to explore is woven into our very nature, pushing us to seek new horizons. Now, that same call beckons us to a much larger ocean. Space. The cosmos is our next frontier, vast and mysterious, waiting for us to answer its call. We've mapped our planet, sent robots to our solar neighbors, but the grandest journey still lies ahead, beyond our sun, into the interstellar void. The universe is full of possibilities, and we are just beginning to explore them. Our dreams of space travel are woven into our culture, inspiring new generations to explore. Children look up and imagine themselves among the stars, building the future with every question they ask. Every great journey begins with a dream, and humanity has been dreaming of the stars for a very long time. These dreams are the seeds of tomorrow's discoveries. The journey from dreaming to doing is the story of science, turning what if into how to. Every breakthrough starts with a question, and every answer leads to new frontiers. Our ancestors saw myths in the stars. We see physics, chemistry, and the potential for life. The night sky is no longer just a tapestry of stories, but a map to worlds yet to be discovered. We've built telescopes that let us see billions of years into the past. With every new instrument, we peel back another layer of the universe's secrets. Now, we stand on the edge of a new era, one where we might not just look, but go. The tools we build today could carry us to distant worlds tomorrow. The dream is becoming a plan. The stars are calling, and for the first time, we are ready to answer. To journey outward, we must first understand our starting point, the solar system, our cosmic neighborhood, and the only home humanity has ever known. At its center is our sun, a gigantic churning ball of hot gas, burning for over 4 billion years. It is a star among billions, yet, to us, it is utterly unique, the source of all warmth and light in our lives. Its energy powers life on Earth, drives our weather, and sustains our existence. Every plant, every animal, every breath we take is a gift from the sun's relentless fusion. The sun's gravity holds the planets in its embrace, dictating their paths and orchestrating the cosmic dance of our solar system. To leave the solar system, a spacecraft must break free from the sun's grip, achieving escape velocity, a feat that pushes the limits of our technology and imagination. This is a monumental challenge requiring incredible speed and energy. The forces at play are immense, and the distances almost unfathomable. Our rockets burn massive amounts of fuel just to escape Earth's gravity. Escaping the sun's is even harder, demanding innovation and perseverance. The edge of our solar system, where the sun's influence fades, is billions of kilometers away. A journey that takes decades for our fastest probes, like Voyager, to reach. This vast region is our cradle, where humanity was born and took its first steps. Here, we have gazed at the stars and wondered what lies beyond. We've explored Mars, Jupiter's storms, Saturn's rings, but a cradle is meant to be left behind. Our curiosity has always pushed us further. To grow and ensure our survival, we must eventually venture out, seeking new worlds and new possibilities. The sun has nurtured us, but the stars are calling. Beyond our solar system lies the vast unknown, filled with promise and mystery. The challenge is immense, but our spirit of exploration is greater still. We are driven by a desire to discover, to learn, and to reach beyond our limits. We are ready to leave the cradle, to take our place among the stars and begin a new chapter in our journey. The next step is outwards. The universe awaits, vast and full of wonder, ready for us to explore. How do we begin our journey into the cosmic ocean? With rockets, a technology less than a century old. Rockets are controlled explosions, pushing mass out at high speed to fight gravity. They've carried satellites, astronauts, and the Apollo missions to the moon. But to go beyond, we needed more robotic explorers, space probes designed to survive the harshness of space for years. These probes are our eyes and hands in the solar system, sending back data from worlds we've never seen. They use gravity assists, slinging themselves past planets to gain speed, a cosmic game of billiards. Our first messengers to the stars are already on their way. The journey has begun. Rockets got us to the moon, but they're too slow for the stars. The nearest star, Proxima Centauri, is over 4 light-years away, a journey of tens of thousands of years with current technology. We need new engines. One idea: solar sails, giant, ultra-thin mirrors pushed by sunlight, accelerating probes to incredible speeds. Another: fusion propulsion, harnessing the power of the sun itself to drive starships at a fraction of light speed. Fusion could cut travel time to decades, but we haven't mastered it yet. The most exotic idea: antimatter engines, releasing pure energy when matter and antimatter meet. Antimatter is hard to make and store, but its potential is enormous. These are the dreams scientists and engineers are working on now. The future of interstellar travel depends on turning these dreams into reality. The next leap will require new physics, new courage. The stars demand it. Why go to the stars? First, to know. Curiosity is at our core. The universe is the greatest mystery, and exploring it is a powerful motivator. We seek life. Are we alone? Finding even simple life elsewhere would change everything. There's also survival. As long as we're confined to one planet, we're vulnerable. Becoming an interstellar species is the ultimate insurance policy. The quest pushes us to innovate, to cooperate, and to become better. The journey to the stars is about what we'll find and who we'll become. We've already sent our first messages into the cosmic ocean. Voyager 1 and 2. Launched in the 1970s, they explored the outer planets, sending back images that transformed our understanding. After their planetary tour, they kept going, on a one-way trip out of the solar system. In 2012, Voyager 1 crossed the heliopause, entering interstellar space, the first human-made object to do so. Voyager 2 followed, both now humanity's farthest ambassadors. Their power is fading, but they still send back whispers from the edge. Each carries a golden record, sounds and images of Earth, greetings in many languages, music, and pictures. It's a message to any who might find it. This is who we were. The odds of discovery are tiny, but the gesture is profound. We have reached beyond our cradle. Our story is out there. What will we find in the darkness between the stars? More stars, hundreds of billions in our galaxy alone. Some are like our sun, Others are giants or tiny red dwarfs. Each star could host planets, exoplanets. Thousands have been found. Some are gas giants, some rocky super-Earths, some orbit two stars. The universe loves to make planets. The most exciting find would be a world with oceans and an atmosphere, a planet in the habitable zone. Our telescopes are searching for signs of life. Oxygen, methane, the fingerprints of biology. If we find life, even simple, it would be the most profound discovery in history. We would no longer be alone. We would be part of a cosmic community. That is the ultimate prize awaiting us. The journey to the stars won't be easy. The distances are vast, the challenges immense, but history shows what seems impossible today can become routine tomorrow. First, we'll send advanced robotic probes, solar sails, fusion engines, reaching nearby stars in a human lifetime. They'll map new worlds, turning points of light into real places. After the robots, perhaps humans will follow, on generation ships or faster vessels. The first to arrive will be pioneers, carrying humanity's hopes. This future isn't fantasy, it's a possibility, a choice. The universe is full of wonders, but we must go to them. Physics allows the journey. The resources exist. The only question is our will. We have the mind to understand, the desire to explore. What we do next is up to us. The stars are waiting. You don't have to be a rocket scientist to join this adventure. The universe welcomes all who are curious, no matter your background or experience. The cosmos is vast, but the first step is simple. Just look up and let your imagination soar. The journey to the stars belongs to everyone. It starts with wonder. Whether you're young or old, alone or with friends, the night sky is a shared experience that connects us all. Every question you ask brings you closer to the stars. Go outside on a clear night, find the Milky Way, and remember, every star is a potential destination. Each twinkling light is a world waiting to be explored, a mystery waiting to be solved. You can be an explorer from home, help astronomers search for new planets, learn the constellations, visit a planetarium. Technology brings the universe closer than ever before, making discovery possible from your own backyard. Read, watch, ask questions. Every curiosity is a step on the journey. Dive into books, documentaries, and online resources. Share what you learn with others and inspire new explorers. The future explorers are alive today, learning, dreaming, building. They are inventing new tools, imagining new worlds, and preparing for journeys we can only dream of. They might even be you. Your ideas, your dreams, and your passion could shape the future of space exploration. The cosmos is calling to everyone, no matter who you are. It doesn't matter where you come from. Space belongs to all of humanity. Your curiosity and dreams are the fuel for our journey. So keep looking up, keep wondering. Every moment of awe brings us closer to understanding our place in the universe. The universe has waited billions of years for us to arise and appreciate its grandeur. Now, it's our turn to explore, to learn, and to marvel at its beauty. We are the means by which the cosmos knows itself. Through our curiosity and exploration, the universe becomes aware of its own existence. The journey has just begun. This is your invitation. The next chapter of discovery is waiting for you to turn the page. Our greatest adventure is just getting started. The cosmos awaits. Will you answer the call?